size of an object in space, and therefore different ways for the moon to be the size of the sun. Does it have the same mass as the sun, or does it have the same volume? If it has the same volume, the moon would physically occupy the same amount of space as the sun does now, while if it has the same mass, it could appear much smaller but would exert the same gravitational influence as the sun does. It's a close run thing, but that second one would probably cause the most chaos. Say the moon remained the same size and shape, but somehow its mass increased to match one's solar mass, or what the sun is now. The first thing to change would be the Earth-Moon system, or the Moon-Earth system as it would become, because the moon would now be the local center of gravity. If that were to just happen suddenly, then the Earth would be quickly and inescapably drawn into the moon, splintering into pieces upon impact. Not good. But if the change could somehow be instantly counterbalanced by how the Earth behaves too, then it needn't be a death sentence. Our planet wouldn't be a planet anymore, it would be a moon, to the moon, which would be a planet. And to have any hope of avoiding that quick, splintery demise, Earth would need to pick up some serious speed through space. Right now, it travels at about 67,000 miles per hour. It's a speed which works really well for orbiting the sun when you're as far away from it as we are, which is about 93 million miles on average. But now, we'd be only the average distance between us and the moon, 239,000 miles, away from something with an equal gravitational pull to the sun. So we'd need to be going a lot faster than even 67,000 miles per hour to survive. Say our corner of the solar system just reset itself to account for this though, and no harm done. What then? Many of the least hostile celestial bodies in the solar system today are moons of the gas giant Saturn and Jupiter. So could we expect a similarly merciful hand? Not at all. If the sun stays the same mass and the moon suddenly inherits an equal mass, and we're caught in the middle of it, then we're essentially caught in the middle of a binary system. A collection of planets, moons, asteroids, and meteors with orbits shaped by not one, but two major gravitational influences. And quite apart from anything else, that would mean a constantly changing distance between the Earth and what would still be our closest star at least, the sun. The moon, even with the mass of our star, could never provide us with everything else the sun does, namely light and heat. So if we were to start orbiting the moon, which would then pull us further away from and potentially closer to the sun than we've ever been before, then it's a sure bet we wouldn't be able to survive some extreme changes in living conditions. Our relied upon seasons would be long gone as our path through space changes completely, and soaring and plunging temperatures would become the norm. All of which means that even if our little world did somehow speed up enough to avoid simply crashing into the moon in the first place, a move which would no doubt affect its rotational speed too, then there's just no telling the path we'd now have to cut through the solar system. There's no predicting the route that gravity would now guide us down. The solar system in general would be reshaped to a totally different layout. Another immediate danger to Earth would involve the tides. As we are, the moon's gravity plays a vital role in the movement of our oceans. It's capable of creating and conducting enormous monstrous waves, with moon-induced underwater or internal waves often registering as bigger than even our tallest skyscrapers. Suffice to say then, were the moon to become as massive as the sun, we'd be totally obliterated by unimaginable surges of water. The oceans, while boiling and freezing at extreme temperatures thanks to our now erratic orbit, would be moved around to totally reshape the world map, putting entire cities and countries underwater and creating whole new stretches of land which had previously been beneath the sea. As it is now, the 93 million mile away sun already exerts some influence over how our oceans behave, with the Earth catapulting around a much closer solar mass then, the waters would simply never settle. It's not just Earth which would feel the effects of this change though. Binary systems are relatively common and stable out in the wider universe, but such a monumental shift could have grave implications for some of the other solar system planets, especially the other inner planets. Mars, Venus, and Mercury would find themselves in much the same situation as Earth, pulled into all new, radically different orbits between the moon and the sun. The outer solar system planets beyond the asteroid belt might fare a little better, with Jupiter still able to exert its own gravitational influence. But even they would now chart a new path through space. Today, we're quite sure on where the solar system's habitable zone is, but it would be a much more difficult prospect deciding where, anywhere life could survive in this new setup. Everything would be out of balance. So that's mass, but what if the alternative happened? What if the moon was as massive as it always has been, but suddenly had the same volume as the sun instead? The first thing you'd notice here is that the moon would now take up the entire sky. In fact, given that the average distance between us and the moon is 239,000 miles, and the radius of the sun is 432,000 miles, it would do more than just take up the entire sky, it would smash us to bits. The only way we could even hope to survive this hypothetical change then would be if the moon also moved further away from us, about 3 or 4 times further away. But if the moon did this whilst maintaining the same mass as it currently has, the problem then would be the link between it and Earth would significantly weaken. On the one hand, this would mean weaker tides here and yet more ecological problems. On the other, the link between Earth and the wildly inflated moon could also break completely, casting the gigantic moon loose to roam around the solar system, like a giant cosmic beach ball. Say it did stick around, however. With the moon so much bigger in our sky, our nights would also be significantly lighter. Moonlight is sunlight reflected from the lunar surface, so make that surface bigger and more light is produced. One plus side is that moonlight, as we currently experience it, doesn't really carry harmful UV radiation like light directly from the sun does, so moonburn needn't be a major concern. There's also the fact that with a bigger moon, we would no longer need streetlights or the energy they consume to see where we're going or to keep safe. On the downside, however, such a change could well prove psychologically and physiologically damaging for humans and all animals that rely on a day-night cycle. Our circadian rhythms would certainly need time to adapt. It's not like the increased light would be totally unavoidable, though. Anyone who lives in a city already experiences more light at night compared to those who live in the countryside. It's just that now we'd all need top-of-the-range blinds or curtains to get a good night's sleep. And finally, the one thing a sun-sized moon would definitely mean is many, many more solar eclipses, to the point where they probably wouldn't even be newsworthy anymore. With these two huge entities competing for space in the sky, they'd be crisscrossing in line with each other all the time. Only because the moon won't have changed mass, meaning we'd theoretically remain the same 93 million miles away from the sun, our life-enabling star would appear tiny next to our sky-covering moon, meaning eclipses would take a long time to pass. So that's what would happen if the moon was the same volume as the sun, and if it was the same mass, we've seen how it would become the gravitational center of a new Moon-Earth system. Which scenario would you prefer? Because that's what would happen if the moon was as big as the sun.